So continuing on with part 2 of the review sheet, and just a remark before we continue, if I'm going too fast on any of these and there's any of the steps that you want to know how I did them or why I did them or anything like that, if we were in person, you could just raise your hand and ask me a question. You can't do that, but you can certainly send me a message. So if you have any questions or anything you want me to elaborate on or explain more fully, send me a message, ask me a question. I'll try to clear up the confusion. So continuing on, we're solving equations. 2x squared minus 11x plus 5 equals 0. That can be factored into 2x minus 1 times x minus 5 equals 0. So either 2x minus 1 equals 0 or x minus 5 equals 0. And then solving each of those, you get x equals 1/2 or x equals 5. Now that's another one that could also be done with the quadratic formula, but if you can see how to factor that, I think that's the easiest way. Number 12, 2x squared plus 8x equals 0. Notice here we only have two terms, but they have a common factor. So if you factor out the greatest common factor of 2x, it's 2x times x plus 4 equals 0. So either 2x equals 0 or x plus 4 equals 0, which gives us x equals 0 or x equals -4 for the two solutions to this equation. Now here the directions say, perform the indicated operations and simplify if possible. Give your answers in lowest terms. So this has to do with that chapter on rational expressions, fractional expressions, and doing operations with those. So here we are dividing. We have one fractional expression divided by another. So remember how you handle division. The first step is to turn it into multiplication of the reciprocal. So we leave the first expression the way it is, turn division into multiplication, and flip the second fraction over. The next thing to do is to factor everything we possibly can so that we can see if we have any common factors that can be canceled or divided out. So the 3x plus 3, we can pull out a 3, so it's 3 times x plus 1. The x squared minus 8x minus 9 factors into x minus 9 times x plus 1. The x squared minus 4x minus 45 can be factored into x minus 9 times x plus 5. And the 2x squared plus 11x plus 5 can be factored into 2x plus 1 times x plus 5. Now, looking for common factors, there's an x minus 9 on top and on the bottom. There's an x plus 1 on top and on the bottom, and there's an x plus 5 on top and on the bottom. And once we've divided those common factors out, what we have left is a 3 on top over a 2x plus 1 on the bottom. So the final answer in lowest terms is 3 over 2x plus 1. This next one is a subtraction problem. Remember, when you are subtracting or adding fractions, they need to have a common denominator. Here, these already have the same denominator, so that makes things easy. We keep that same denominator and just subtract the numerators. We're taking 2x minus 3, and we are subtracting x minus 4, and that means we're subtracting the x, and we are subtracting the minus 4. Minus a minus is the same as a plus. So that's why I wrote it as minus x plus 4 here. So the 2x minus x is x. The minus 3 plus 4 is plus 1. And we get x plus 1 on top. Meanwhile, what we have on the bottom is x squared minus 6x minus 7, which can be factored into x minus 7 times x plus 1. So now I notice there's a common factor of x plus 1 on top and on the bottom that I can cancel out. When I divide that out, what's left on the bottom is x minus 7, and what's left on the top is just 1. Remember, when you have x plus 1 and you divide by that whole thing, anything divided by itself is 1. So that's why when I divide out the x plus 1s, I just have a 1 on top, and I still have an x minus 7 on the bottom. Number 15, here we are adding, and I just said when you're adding or subtracting, you need a common denominator. Here, these do not have the same denominator, so we need to fix that before we can add them together. And the way we fix that is to get them to have the same denominator. I can take the first fraction and multiply by what's missing in this denominator, x minus 3 on top and on the bottom. So that turns it into something with a denominator of x plus 9 times x minus 3. And then I want the second fraction to also have a denominator of x plus 9 times x minus 3. So I multiply it by x plus 9 on top and on the bottom. So now we got x times x minus 3 over x plus 9 times x minus 3, plus 4 times x plus 9 over x plus 9 times x minus 3. Now that they have the same denominator, we keep that same denominator and combine the numerators. We've got x times x minus 3, or if you multiply that out, that's x squared minus 3x. Plus, if you multiply this out, it's 4x plus 36. And if I combine the x terms in the middle, what I get is x squared plus x plus 36 on top over x plus 9 times x minus 3 on the bottom. Now, if you wanted to multiply that back together on the bottom, you could. You could write it as x squared plus 6x minus 27 on the bottom, or you could just leave it in factored form. And the numerator cannot be factored, so there's nothing more to do with that. Number 16, here's another one where we are subtracting, and before we can subtract, we need these to have the same denominator as each other. This time it's going to be a little bit more complicated to get a common denominator, but to see how to do that, I'm going to start by factoring the denominators we have. The x squared minus 5x factors into x minus 4 times x minus 1. And the x squared minus 7x plus 12 factors into x minus 4 times x minus 3. So they do both already have a factor of x minus 4. But the first one has an x minus 1, but it does not have an x minus 3. And the second one has an x minus 3, but it does not have an x minus 1. If we want them to be the same and have all the same factors as each other, the first one's missing the x minus 3, so I multiply by x minus 3 on top and on the bottom of the first fraction, which turns it into x squared minus 3x over x minus 4 times x minus 1 times x minus 3. And then in the second fraction, I multiply by that missing factor of x minus 1 on top and on the bottom, which gives me x plus 1 times x minus 1, or if you multiply that out, that's x squared minus 1 over x squared minus, or x minus 4 times x minus 3 times x minus 1 on the bottom. So now that they have the same denominator, keep that same denominator and combine the numerators. We got our x squared minus 3x minus our x squared minus 1. So we're subtracting x squared and we're subtracting negative 1. The x squared minus the x squared cancels out, and then we still have a minus 3x and a minus minus or a plus 1. So the final answer is negative 3x plus 1 on top over x minus 4 times x minus 1 times x minus 3 on the bottom. And then number 17, we are multiplying. So remember when we divided, the first thing we did was to turn it into a multiplication problem. Well, this is already a multiplication problem, so we go straight to the step where we factor everything we can, and then we can look for common factors we can divide out. So 4y squared, there's nothing to really factor out there, but keep in mind that means you got a 4, which is 2 times 2, times a y squared, which is y times y. The 12 minus 2y has a common factor of 2 that you can pull out and write it as 2 times 6 minus y. The y squared minus 36 is a difference of two squares. It can be factored into y minus 6 times a y plus 6. And the 5y squared plus 11y plus 6 can be factored into 5y plus 1 times y plus 6. Now we go looking for things we can cancel. There is a factor of y plus 6 on top and on the bottom, so we can just divide those out. There's a y minus 6 on top, and there's a 6 minus y on the bottom. And those aren't exactly the same as each other because the subtraction's in the opposite order, but they are opposites of one another. We can pull out a -1 and then they would be the same. So we are allowed to cancel those, which leaves us with a factor of -1 behind. And the 4 on top over the 2 on the bottom, 4 divided by 2 is just 2. So that leaves us with a 2 on top. The y squared doesn't have anything to cancel with, and the 5y plus 1 on the bottom doesn't cancel with anything. So what's left is the minus 2y squared over 5y plus 1. Now we're solving equations that involve rational or fractional expressions. So our plan of attack for solving an equation like this is first factor the denominators so we can see what we would need to do to cancel out all those denominators. So in this case, the x squared plus 2x minus 3 can be factored into x plus 3 times x minus 1. So one of these fractions has a denominator of x minus 1, one of them has a denominator of x plus 3, and one of them has both of those factors multiplied together. So the lowest common denominator of all the fractions would be an x plus 3 times an x minus 1. If we multiply through by that, by x plus 3 times x minus 1, that is going to enable us to cancel out all of the denominators. So that is the next step. Take this equation and multiply both sides by x plus 3 times x minus 1. So when you do that, the x minus 1 times the x plus 3 times the 5 over x minus 1, well, the x minus 1 over x minus 1 cancels and leaves you with just the 5 times the x plus 3. So no more fraction there. Plus, when you take your x minus 1 times your x plus 3 times your 3 over x plus 3, there the x plus 3 over x plus 3 cancels. And what you have left is the 3 times the x minus 1. No more fractions there. And on the other side, we took our 4 over x plus 3 times x minus 1, and we multiplied times x plus 3 times x minus 1. So both of those factors canceled, and we just had the 4. So now we've reduced it to an equation that no longer involves fractions. So we can continue on by multiplying things out to get rid of the parentheses. 5x plus 15 plus 3x minus 3 equals 4. Combine like terms. The 5x plus 3x gives you 8x, and the plus 15 minus 3 combines to plus 12. So 8x plus 12 equals 4. Subtract 12 on both sides, you get 8x equals -8. And then divide both sides by 8, and x equals -1. And there's one more thing I need to think about. I need to make sure that if x is -1, that does not give me any zeros in denominators in the original equation. So if I go back up here and check, if I put in -1 for x, well, a -1 minus 1 would be a -2 here. A -1 plus 3 would be a +2 here. This would be, well, it wouldn't be 0. So We don't have zeros in any denominator, so that is the solution. It does work.